Okay, so we're going to look at this first problem. It says solve the following polynomial inequalities. Give your answer in interval notation. Show all work. So this first one we have x plus 4, x minus 1, x minus 3, greater than or equal to 0. Okay, so this one's set up a little bit easier for us, and we can see that these are going to be our three factors, right? Because if we were to plug in like -4 into this first one, we would get 0, which would make the whole thing 0, etc. So what we can do is we can draw a number line to help us figure this out. So we have -4 here, we're going to have +1 here, and +3 here. And it says we want these to be greater than or equal to 0. So since putting in these x values is going to give us 0, then we can say that all of these are included. So we can put a little dot here on each of these. Okay, so then we need to check to see if these like regions here are going to give us a positive or a negative number when we use points in them, because we want this to be greater than or equal to 0. So we want it to be positive. So if we come back here and we say and if we use -5, if we plug in -5 into this equation, we will get a negative number here. Plug in -5 here, we'll get a negative number here and a negative number here. So a negative times a negative is a positive, but times a negative is a negative. So this region is out. Okay, so let's check this next region. So if we plug in okay, so what about -2? So we plug in -2 to here, we get a positive number. Plug in -2 to here, we get a negative number. Plug in -2 in here, we get a negative number. Well, negative times a negative is a positive, times a positive is a positive. So this region is good. We want to use this region. Let's talk about this region here. If we put in +2, what's going to happen? So if we put in a +2 to here, we'll get a positive number. If we put in +2 to here, we'll get a positive number. If we put in +2 to here, we'll get a negative number. So positive times a positive is a negative, times a negative is negative, and we need this to be positive. So this region's in, this region's out. Let's do this last region. What if we put in a +4 into the equation? So if we put in a +4, we get a positive number here. We get a positive number here, and we'll get a positive number here. So then this region is also good for us to use. So now we can rewrite our number line a little bit clearer. And we can say we have -4, 1, and 3. And we can say that we have this included, we have this part included, we have this included, and then this goes to infinity. So writing that, we can say -4 to 1, union 3 to infinity. Our next one, we have z squared is less than z plus 20. So our first step is going to be moving everything to one side. So we have z squared minus z minus 20 is less than 0. So now we need to find two numbers that multiply to -20 and add to -z. So let's think. So we know that 5 and 4 multiply to 20, and they're really close together. So what if we do -5 and 4? So -5 times 4 is -20, and -5 plus 4 is -1. So that checks. So let's do -5, or not -5, x minus 5 times x minus 4, or plus 4, sorry. It's less than 0. So our same concept here is going to be that we draw our number line. So then we're going to put our points at -4, right, because that would give us a 0 there, and +5, which gives us a 0 there. And so now it's time to check our intervals, right? So if we have a number smaller than -4, say we have -5, what's that going to do? Let's do, -5 minus 5 is going to be -10, and then -5 minus 4 is going to be a negative number as well. Negative times a negative is a positive, and remember, we're looking for a negative number. So this section is not going to work for us. So let's look at our next section. What if we have a number between -4 and +5? Alrighty, well, let's think about it. Let's choose a fun number in there. Let's do +2. So we have a +2. We have 2 minus 5, which is going to be a negative number. And then we have +2. We have +2 plus 4, which is going to be a positive number. So this is a negative times a positive is going to give us a negative number, so this section does work for us. All right, now checking our last section, we have a number bigger than +5. So let's do like 6. So if we have 6 minus 5, that's going to be a positive number. If we have 6 plus 4, that's going to be a positive number. Positive times a positive gives us a positive, and we are looking for a negative number, so that section doesn't work. So now we can redraw this number line a little bit better, so we can draw our points. So we have -4 and +5, and since this is strictly less than and does not have an equal sign, we're going to need to account for that. We cannot have these points in here. So we're going to give us a little circle here. We said that this section doesn't count, but only our middle section counts. So using that, we can see that our interval should be -4, 5 with parentheses and not brackets. All right, next one is number 2, part A, where it says, solve the following rational inequalities. So we have x minus 2 over x squared minus 9 is greater than or equal to 0. So our very first step is to just figure this out really quickly. We're going to multiply both sides by x squared minus 9. Multiply by x squared minus 9, but we can't forget about it, so keep it in the back of your head. That's going to be 0, so then we get x minus 2 is greater than or equal to 0. We can just solve this inequality. And so +2 plus 2. We have x is greater than or equal to +2. So we need that. So we're going to hold this off to the side over here in a little box. Box this up. That's important. But we cannot forget about this x squared minus 9. So when you think about, are there going to be any problems with this x squared minus 9? Because we can't just get rid of it like we did. We have to, it's still there and it still matters. And so our only problem would be if when this is equal to 0, because then we would have a 0 in the denominator, and we can't have that. So let's think about that. So we're going to have x squared minus 9. When is that equal to 0? Well, we have add 9 to both sides. If x squared is equal to 9, we take the square root of each side. We get x is equal to plus or minus 3. So at +3 and -3, the denominator is going to be 0, so we definitely can't have those. So let's draw us a fun little number line. Okay, so now that we have this number line, we can plot down all these points that matter to us. So -3, we have our +2, and then our +3. Something we know already is that we definitely can't have this 3, right? Because that would give us a 0, so we're going to have to have a hole there. But we know that this 2 is included. So now we need to check all of these intervals. So remember how we check these intervals. So if we have a number smaller than -3, like say -5, if we put a -5 into the denominator or the numerator, we'll get a negative number. And then on the bottom, if we have a -5, we would have like negative 5 squared, which is 25, minus 9, which is a positive number. So this gives us a negative number, so we can't use this section because we're looking for positive numbers. If we continue this theory throughout this middle section here, if we do like positive 1, on the top we're going to get a negative number, and on the bottom we're going to get a negative number. So we can use this interval, and then our next section. So this one may look confusing, but it's actually a little easier. We know that 2 is included here, but 3 is not included here. And I know I drew the gap a little bit bigger, but it doesn't really matter because we can just write it as 2 with close parentheses union 3, right? Because we can say that 2 is included, but 3 is not included. So then we want to look at this next interval here. And this one is already kind of said for us. We can say that x greater than or equal to 2 is included. So if this is greater than or equal to 2, it is included with the exception of 3 here. So now that we have all that information, we can finish writing this inequality here. And we can say we need this included here. It's kind of far away. So this is our final inequality. So our next one is going to be 3 over 4 minus x is equal to 6 over 1 minus x. So we can do some cross multiplying here and multiply this side by 1 minus x and this side by 1 minus x. So we get 3 times 1 minus x. And we can also multiply both sides by 4 minus x. Multiply by 4 minus x. So then we'll get this is less than or equal to 6 times 4 minus x. Simplifying that out, we'll get 3 minus 3x. It's less than or equal to 24 minus 6x. Great, so now we can move everything to one side. We can add 6x. So we have 3 plus 3x less than or equal to 24. Subtract 24. We'll get negative 21 plus 3x is less than or equal to 0. Actually, we can just solve from here since we don't have an equation. We can add 21 to both sides. 3x 21 divided by 3. X is less than or equal to 7. Okay, so like last time, we need to hold on to this. Put it up there. And then we'll be able to see what we're looking at. So we're going to take this. We're going to put it up here in the corner. And we're going to save it for later. Okay. So looking back, we have 3 over 4 minus x less than 6 over less than or equal to 1 minus x. So remember, we don't want these denominators to have zeros in them. So we can see that if we have a negative 4 in this one, that's going to be a problem. And if we have a positive 1 in this one, not negative 4, positive 4. If we have a positive 4 or a positive 1, those are going to be problems. So now we can draw our number line, keeping our x has to be less than or equal to 7 in mind. So we have 1, 4, and 7. And we know that we cannot have 1 or 4. Big zeros there. But we know that 7 is included. And we also know that this is where it stops on the left-hand side because x has to be less than or equal to 7. So now we want to check our intervals. So we know that we have to check these intervals. So let's find a number between 4 and 7, something like 5. And let's check to see if this will follow our condition. So if we have some number 5 in this first fraction, we'll have 4 minus 5, which is negative 1. So we'll have 3 over negative 1, which is just negative 3. And then if we have some number 5 in this equation here, we're going to have 1 minus 5, which is negative 4. So we're going to have 6 over negative 4. And if we put 6 over 4 into our calculator, we get 1.5. So we know that negative 3 is smaller than negative 1.5. So this section here works for us. Great, so let's check this next section in between 4 and 1. So if we pick some number like 3, if we have 3 over 4 minus 3, we're going to get 3 over 1. And then on this side, if we have 6 for 1 minus 3, we're going to get 6 over negative 2, which is negative 3. And we know that positive 3 is not smaller than negative 3, so this section does not work for us. All right, this last section we need to check is if it's smaller than 1, so we can put an easy number in like 0. So if we have 3 over 4 is less than or equal to 6 over 1, which is just 6. And we know that is true because a fraction is less than a whole number, so this section also works. So then we can write our inequality from this, and we can say negative infinity union 1, close parentheses, union, or open parentheses, 4, 7. So we know that that 1 and those 4 are not included, but those sections next to them are. So it gives us an equation and it asks to find for what time will it be more than 18 feet high. So we can just say that when is this function greater than or equal to 18? So negative 16t squared plus 40t plus 2. We want this to be greater than or equal to 18 because our S of t gives us our position. So what we do now is we need to set this equal to 0. So we get negative 16t squared minus 40t minus 16 is greater than or equal to 0. So we can use the quadratic equation to figure out when this left side is equal to 0. So the quadratic equation is going to be negative 40, so positive 40, plus or minus the square root of negative 40 squared minus 4 times negative 16 times positive 16, all over 2 times negative 16. So plugging that into our calculator. So we know our factors are going to be x minus 1/2 and x minus 2. So then we know that when x is equal to 1/2 and when x is equal to 2, we have this equation equals 0. And we know that this function is a quadratic, and so it looks something like this. And so if this line is like 18 feet, we just determined that at this point, 1/2, and at this point, 2, is when that ball is greater than or equal to 0. So we can see that our interval for when the ball is going to be higher than 18 feet is going to be 1/2, this 1/2, 2, 2. So that will be our interval. Except it's asking us when it's more than 18 feet above the ground. And we found that these points are when it is 18 feet above the ground. So we need to make sure these are closed parentheses. All right, for this next problem, it's asking us for during what intervals would would word of mouth maximize profit. So it's giving us these two equations. I want to know when this equation is less than t plus 2. So again, this is pretty standard. We're going to set this equal to 0, minus t minus 2. So we have 1 over 7 t squared. Then we'll have negative 11 over 7t, and then that will be it. We won't have that 0. There's an imaginary 0 right there. So it's less than or equal to 0. So now we want to figure out for what values of t is this inequality less than or equal to 0. So we can factor out a t here. We say 1 over 7t minus 11 over 7, right? It's less than or equal to 0. And due to our zero product property, we know that if either one of these factors is equal to 0, then the function is equal to 0. So we know that when t equals 0, that this is going to be less than 0. And then we can do the same thing with this middle function here. We can say 1 over 7t minus 11. We want to know when that is equal to 0. So if we add 11 over 7, we get 1 over 7t is equal to 11 over 7. If we multiply both sides by 7, we get when t is equal to 11. So these are our two factors. So now we have t equals 11. So we know that this is going to be the interval where this is, where profit or PA is less than PM. So our interval is going to be, close parentheses, because we don't have an equal sign, 0 to 11 days. So doing these next ones, we want to look at, determine if the relationship defines y as a function of x. So our biggest thing we need to look for, that every x value only has one y value. So if we look here, we have negative 10 is our only x value, negative 2 is our only x value, 6 is our only x value, 14 is our only x value. So each of these x values have one y value. We have, so then we know that a is a function. Yes, it is a function. For b, same thing, we want to make sure each of these y values only have one x value. So each of these x values only have one y value. So, each x value has only one y value here. Some of them might be the same, but that's okay. There's no y value that shares an x, so that's good. So b, yes, it is a function. However, this one, if we look at c, blowing this picture up, we can see that if I look at this x value 1, it has y values 2, 4, negative 2, and negative 4. So this x value has 4 different y values, which cannot happen for it to be a function. We can also see that this fails the vertical line test, right? If we draw a vertical line, if we have this vertical line and we drag it this way, we can see that at multiple points, this line touches multiple points. So that fails our vertical line test, so this is not a function.
Number 6, determine if the following graphs represent a 1-to-1 function. So this one, we're going to use the vertical line test and then the horizontal line test. So the vertical line test, we can see that a is indeed a function, but the horizontal line test means that there are multiple outputs, or the same output for multiple inputs. So a is not 1-to-1. B, we can again use the vertical line test to show that it is indeed a function, and then the horizontal line test means that as we cross over, we'll see that for every input there's exactly one output. So B is 1-to-1. And then C, it immediately fails the vertical line test. So the only one that is 1-to-1 is graph B. 7, use composition to determine if the functions are inverses. So for part A, we'll do f composed of g, which will be anytime we see an x, we'll put the g of x. So the first thing we'll see is x minus 3, so that x will be replaced with 4x minus 3, and minus 3, all divided by 4. So this will simplify to 4x minus 6 over 4. And then we will compare g of x, g of f of x. Which will be 4 times x minus 3 all divided by 4 minus 3 g of f of x is equal to x minus 3 whenever we distribute. Sorry, that's just a single distribution. Minus 3 g of f of x. When we simplify that, it will be x minus 6. G of f of x does not equal f of g of x. So they are not inverses of each other. So then we can look at h and k. B. So we'll look at h, k of x. So this is going to be 4 over x plus 4 divided by x plus, minus 1. So we are going to want to get a common denominator down in the bottom, in which case will be x. So then we'll get h of k of x is equal to 4 over x, which will equal 4 over 1 times x over 4, which is equal to x. Now we'll do k of x, k of h of x. So anytime we see x, we'll replace it with h of x. So 4 over x minus 1 plus 4 all over 4 divided by x minus 1. So I'm going to want to get this fraction on top the same. So we'll end up with x minus 1 plus 4 x minus 1. All of this over 4x minus 1. So this is going to be 4 plus 4 x minus 1 over x minus 1 multiplied by x minus 1 over 4. This x minus 1 will cancel out with this x minus 1, and these will simplify down to x, or 1 plus x minus 1 equaling to x. Since they are equal to each other, they are indeed inverses. A one-to-one function is given. Use inverse function notation to write an equation for the inverse function. Show all work. So this part, A will be, all right, x is equal to 8 minus f inverse of x all over 5. We're going to then solve for this f inverse. So multiply both sides by 5. Subtract 8 from both sides. I'm going to rearrange this. Now we're going to multiply everything by that -1. We'll get 8 minus 5x. Now the g of x function, we'll swap that again. So this will be x is equal to 4 times g inverse of x cubed plus 2. Subtract 2 from both sides. Equal to 4 g inverse of x cubed. Divide both sides by 4. And then take the cube root of both sides. All right, so x for this last one, h inverse of x minus 4 over h inverse of x plus 2. So we're going to want to somehow get these combined in some way. So I'll multiply this over. Distribute this x. So I'm going to get all over h inverses on one side and all over x's on the other, or all of our non-values on the other side. So that's going to leave us with h inverse of x minus h inverse of x equal to -4 minus 2x. Factor out this h inverse. X minus 1 is equal to 2x minus 4. Just rearrange that one. H inverse of x will be 2x minus 4 over x minus 1. Determine if the function in the restricted domain would be a one-to-one function. If it is one-to-one, find the inverse function, use inverse function notation, show all work. So we can start by graphing that. So here at -3, be a parabola, and then once we hit the x equals 0. So we can see that it indeed passes the vertical line test, but it does not pass the horizontal line test, so it is not one-to-one. Okay, now for B, let's graph that. -1, we're looking at x strictly greater than that, so should get this. Obviously it passes the vertical line test, and we can see that it passes the horizontal line test as well too. So it is indeed one-to-one. So, and then say x is equal to 2 g inverse of x squared minus 1. Okay, x plus 1 is equal to 2 g inverse of x squared. Divide both sides by 2. Take the square root of both sides. So, and then we're purposely choosing the positive portion of this because of our domain restriction. And then our domain here is restricted to x is greater than or equal to -1. All right, graph the exponential function. F is equal to 1/3 raised to the x. Make a table with at least 6 points to plot. Write the domain and range. If the function, write the domain and range of the function in interval notation. So we'll do x, f of x. Let's start with what? -3, -2, -1, 0, 1, 2, 3. That's 7 points, but that's at least 6. So at -3, our f of x will be 27. -2 will be 9. This should be 3. 0 is 1. And we'll get 1/3, 1/9, and 1/27. So if we want to plot this, okay. So at -1, we're at 3. At -2, we're at 9. And 27's way out there. At 0, we're at 1. Then we get to like 1/3, 1/9, 1/27. Come in like this. All right, and then the domain and range. So the domain of this first one should be from -infinity to infinity. Its range will be from 0, non-inclusive. It looks like it does get really, really close to 0, but it will never actually touch 0. And then we can see on this left side as we're going towards -infinity, we approach positive infinity with that range. Given the graph of f of x is equal to 1/2 to the x, graph g of x is equal to 1/2 raised to the x minus 3 plus 2. State the shifts from the parent graph function f to the given function g. This is not displayed here, but is on your review sheet. The graph, I've selected a few points of consideration from the parent graph. I'll write down here. So from f of x, we get the following ordered pairs: -1, 2, 0, 1, and 1, 1/2. So, and then the transformations. Are going to be, it'll shift right 3 units, and then shift up 2 units. So now in our g of x, going to do that to each individual point that I selected here to get kind of a pinpoint those exactly, and then be able to graph them. So this -1, 2 will add 3 to the x value and add 2 to the y value, so we should get 2, 5. The 0, 1 will go to 3, 3, and the 1, 1/2 will go to 4, 2.5. So now if we start graphing those, three, 4, 2.5. And then just for fun, we should do when x equals 0. So if we plug that in, we'll get 0, 10 on our g of x. So we'll get that graph transformation of our g of x. All right, 12, given f of x is equal to 2 to the x and g of x is equal to e to the x, evaluate the following at the given values of x, round to 4 decimal places if needed. So f of -3 will be 2 to the -3rd. Put that into the calculator, we'll get 0.125. G of 2 will be e to the 2, should be 7.3891. F, the square root of 15, 2 to the square root of 15. And that should give us 14.6516. And g to that symbol is called pi. E to the pi is equal to 23.1407. 13. If an $8,000 investment is invested at 4.5% per year for 5 years, determine the amount in the account under the following compounding options. So if it's compounded annually, we'll use A is equal to P1 plus R over N to the NT. In this case, we're still trying to solve for the amount. 8,000 is our principal. For part A, it'll be plus 0.045. There's only one compounding thing annually, so any of these equal to 1, so we get that 1 times 5. If we plug that into the calculator and round to the nearest cent, we'll get 9,969.46 dollars for part A. So similar setup, but now we're compounding quarterly. 0.45, we'll divide that by 4 this time, but then our n up here is also 4 times 5. So the amount that we'll get here should be, after rounding, $10,006 even. Now compounded monthly, 0.45 divided by 12, 12 times that 5, and if we put that into the calculator, we should get $10,014.37 compounded daily. Be again the 8,001 plus 0.045, that rate, divided by, while not true every year, it is always assumed that there are exactly 365 days in a year, times that 5, and we'll get this amount of $10,018.44. And then E, slight typo, also a slightly different equation. So that should say compounded continuously. So that changes the equation to P, that natural number E, the RT, in our case, the 8,000 E to the 0.045 times 5. Plug that into the calculator, we'll get $10,018.58. In 2010, the World Factbooks gave the population of the United States as approximately 310 million, with a 0.97% annual growth rate. At this rate, the population P of t in millions can be approximated by P of t equal to 310 times 1.0097, all raised to the t, where t is the time and years since 2010. Given this information, is the graph of P increasing or decreasing? So where that base is greater than 1, it is increasing. Evaluate P of 0 and interpret its meaning in the context of this problem. So if we plug in P of 0, that'll be 1.0097 raised to the 0, which will equal 310 million people. So in the context of this problem, that's 310 million people living in the United States in 2010. Evaluate P of 10 and interpret the meaning, round the population to the nearest million. So that would be 310.0097 raised to the 10. Calculator will spit out 314.41, we're to round to the nearest million. So 341 million. That means 10 years after 2010, or in 2020, we would expect the United States to have 341 million people. Use the model P of t to predict the population of the United States in 2032. Round to the nearest million. So again, we start off at 2010, so 2032 is 22 years after. .097, so in function notation that'd be P of 22. Raise that to the 22nd. And again, if we put that in the calculator, it should give us 383.3, and then we're to round to the nearest million. So 383 million people.